Hello! Today I'm going to explain a proof for the law of cosines using some of the more simple trigonometry rules. So it should be easy to understand as long as you know about SOHCAHTOA, the Pythagorean theorem, and the trigonometric identity sine squared of theta plus cosine squared of theta equals 1. Let's start with some arbitrary triangle. Let's say we know side lengths A and B as well as angle theta adjacent to those two sides. And we're going to try and solve for side length C, which is opposite of theta. From our limited set of knowledge, you would think this would be hard, but it's actually pretty simple after this one step. All you have to do is simply draw a line like this to turn the triangle into two right triangles. Now, all we need is the side lengths of the triangle with side C. So let's define some new variables. Now, first we're going to define side D, which is going to be right here at the bottom of that left triangle, and then side E will be here on the bottom of that right triangle. Let's also define this vertical side here as side F, because we're going to need both E and F, but as you'll soon find out, to solve for E, we're going to need to solve for D first. We're going to solve for D first because we don't really know anything about that other triangle other than that there's a 90-degree angle. So we're going to use one of our rules from SOHCAHTOA, which in this case is the ka part of that, which states that the cosine of angle theta, at least in this case, is going to be equal to that side length D over side length A, because it's the adjacent side to theta over the hypotenuse. Now, what that also means is that D is actually equal to A multiplied by the cosine of theta. We can then also use this information to solve for side E, which is just going to be side B minus side D. And since we just solved for D, we know it's going to be equal to B minus A times cosine of theta. That's one of the sides we need down, but now we need that F. We can do a very similar thing to solve for F though, just using SO this time, which in this case means that the sine of theta is equal to F over A. Just like last time, we can move around the equation a little bit and find that F equals A times the sine of theta. Now that we have all our side lengths, we can just use the Pythagorean theorem to solve for side of C squared. We know that in this case, that's going to mean that C squared is equal to E squared plus F squared. And if we just fill in those variables with what we just solved for, we get the full equation C squared equals B minus A times cosine of theta squared plus A times sine of theta squared. Now that we have our equation, let's expand it out a little bit and make it something that is, well, that we can simplify easier. So if we do that and we move around all these variables, we get C squared equals A squared times sine squared theta plus B squared plus A squared times cosine squared theta minus 2 times B times A times cosine of theta. Now, that last part sounds a little confusing, but that's just the B minus A times cosine of theta squared. If you just do it out like this, you can figure it out. Now that we have this equation, though, we can simplify it a bit further. And if we do that, then we get this. C squared equals A squared times sine squared theta plus cosine squared theta plus B squared minus 2 times B times A times cosine theta. Now, if you're paying attention, you might have already spotted how this is about to go, how we're already basically at the law of cosines. And it's that last simplification we just did. See, with the trigonometric identity that we mentioned a little bit earlier, we know that inside that A squared times sine squared theta plus cosine squared theta, that really just means A squared times 1. Because sine squared theta plus cosine squared theta is always equal to 1. So that means that we can simplify our equation all the way down now to C squared equals A squared plus B squared minus 2 times B times A times the cosine of theta. And if you know about the law of cosines, you know that's it. We just got it. I mean, I guess technically, maybe in more traditional notation, you'd replace theta with like angle C, but either way, that's it. And now you know where it comes from. And if you ever let's say you're on a test or something and you needed to, you forgot the law of cosines. You can just figure it out with at least what I think are probably some of the simplest equations that we have. And so it's good to remember those equations because if you're ever in a pinch, there you go.